All right, so let's get this started. Hi, my name is Christian, and I'll be talking about the LTTNG project, but more specifically about the UserSpace Tracer. So I want to know before I begin, any of you had a similar situation as this? You have an application that crashes in the field, and your boss tells you, well, I have a core dump, good luck. Or another situation where you have some latencies, but you're not able to reproduce it on your development machine. You know, the famous, it works on my machine. So hopefully with UserSpace tracing tools, we'll be able to solve these problems easier. So like I said, my name is Christian. I work at Efficios, a research and development consulting company. We are behind the maintainership of the LTTNG project. I've been contributing to the LTTNG project for about a year now, and also I contribute to other open source projects. So today what we'll see will be an overview of the LTTNG 2.x toolchain, mainly the motivation behind it, and we'll see a technical overview of the UserSpace Tracer. How does it work? How can you instrument your applications to be able to use them with the UserSpace Tracer? Also, we'll see different UserSpace instrumentation sources, such as the Tracepoint, the Uprobes, and also SystemTAP statically defined Tracepoint. We'll also talk about the trace format standardization efforts that we've been doing with the common trace format and where we are going with this. And finally, we'll have some interesting issues that we've had during the development of the UserSpace Tracer, and we'll present also recent features and future work that we plan to do on the project. So before I begin describing the LTTNG 2.x toolchain, before that, like a year ago, we released the 2.0 toolchain. Before that, we had two separate tracers. We had the kernel tracer and the UserSpace Tracer. Both were, there were two sets of tools to interact with both these tracers. And for the kernel tracer, you had to patch your kernel to actually use it. But now, the goal, the motivation behind the 2.x toolchain was to unify these tools and have only one set of tools to interact with all these tracers. So like I said, right now we have a unified user interface, API, so the user has only to interact with one command line tool, the LTTNG tool. By specifying, let's say, LTTNG-UserSpace, you just talk to the UserSpace Tracer, or -k, you talk to the kernel tracer. So this is really easier for the user. We also have a output. The trace output is now in a unified format, and what that allows is that we can correlate the traces from UserSpace and from kernel space and have see all the events through the whole software stack. Also, we strive to have a lower veg tracing, because if we want to be able to use it in production, it has to have lower veg to not impact the running system. And also, right now, we're shipping distro, which is quite nice because it lowers the barrier of entry for tracing. So a little bit of overview. We have mainly three types of projects in the LTTNG project. We have the tracers, we have the system utilities, and we have the viewers. For the tracers, we have the LTTNG Modules, which is a kernel tracer. This is no longer a set of patches that you need to apply to your kernel and run a custom kernel. This is a kernel module that is compatible from kernels ranging from 2.6.38 to 3.8. And we have the UserSpace Tracer, which is responsible, which is a pure UserSpace implementation of pure UserSpace implementation, which is an in-process library that runs alongside your application and is responsible of capturing the events in your applications. We have the system utilities, the LTTNG tools project. This is the main command line that you will use to interact with the tracers. So this is the LTTNG command line, but we also have the session daemon, which is responsible for registering tracing sessions throughout when you try to trace it. And we have the consumer daemon, which is responsible to consume the data received from the application and write them to disk efficiently. And we recently introduced the relay daemon, which is in fact which is responsible of writing traces received from the network to the disk. So we now have a streaming functionality. Finally, we have some viewers. We have the Babel Trace viewer, which is a simple command line tool. It can also act as a trace converter and has an easy plugin system, so we can convert between all types of trace format. We have the LTTng top, which is a top-alike viewer, which is more intended for system administrator, and it replaces the traces in real time. So you can see, oh, okay, what's my CPU activity, what has been my IOs, what FDs were open, etc. And finally, we have a full-blown Eclipse plugin with various views, and it's easily extendable to add some custom views for your workflow or for your applications. So we'll begin with the overview of the UserSpace Tracer. Like I said, it's a pure UserSpace implementation. There's no going back to the kernel or a trap or whatever. It's, how does it work is that we have a shared memory segment between, a shared memory map, I would say, between the applications and the trace consumer. And one of the nice facts of a pure UserSpace implementation, it's also portable to other operating systems. Right now it's working on the BSDs, and also we have an experimental Cygwin port. It's really optimized for low overhead and high throughput. One figure I have in mind is 200 nanoseconds per event to log an event. How do we achieve that is by using a generic kernel ring buffer that was ported to UserSpace, but was originally intended to use in the kernel or for the kernel tracer in LTTng. And we also use efficient concurrent data structures that for tracing control. Most of them are provided by the UserSpace RCU library, which is a RCU implementation in UserSpace. Also, one of the things, all the instrumentation in the UserSpace tracers is statically defined. So you have to instrument your code to have instrumentation, but they can be dynamically enabled. So what that means is that you can ship instrumentation in your code, and in production, when you have an issue, you can decide to enable such or such trace point. Also, one of the nice things that we have is that we're not constrained to only one user using tracing or a root tracing. We can have both, actually. We can have user A and user B tracing their applications, but we can also have a system-wide tracing capabilities with the help of the tracing group. So if you are a member of that, you'll be able to see all the traces of all the applications that registered to that session daemon. And finally, the design of using a shared memory segment allows to recover traces after any application crash. So how does it work? Like I said, you need to instrument your applications with Tracepoint, which we'll talk about later on. And then you link your application with the LTTng-UST, which is an in-process library. And then when your application is instrumented, you need to set up a session. So you create a session, you enable the events that you want to have in your trace. You start your applications, you collect the traces, and then when your application is finished, you can do post-analysis with any viewers. This is really a simple use case. You can have more complex situations, but right next we'll look at a typical tracing session setup and how does it work. So you need to set up a session with the LTTng command line. How do you do that is by calling LTTng-create, which will create a default session. And then you enable the events, the UserSpace event. Right now, this command enables all the UserSpace events, but you could specify, okay, I want to enable that or that event, or specify wildcards. And finally, you start tracing with the LTTng start command. So right now, you have your session set up, an application startup, and what will happen is this. we spawn a thread before via a constructor. This is before main. The application has not started executing its code yet, but we spawn a thread that is responsible of communication to the session daemon and to register to the session daemon. So basically what it tells the session daemon is, hi, I'm this application, I have this PID, and yeah, that's it. And then we send the shell memory and file descriptors through the Unix socket to the session daemon, and then it passes them to the consumer, which maps them in memory. So effectively, we have a channel of communication between the application and the trace consumer. There's also a pipe on the right, so we'll talk more about that later. So this was before entering main, before your application was running. But now that your application is running, if you have any trace point enabled, it will enter the trace point, and then it will write events to the shell memory segment in the ring buffer. When the ring buffers, the sub-buffers of the ring buffer are full, they will be, it will send a notification to the consumer daemon to consume the data. And so that we notify the consumer when the data is ready. And then when your application exits or fails, you will be able to view the data that you just saved to disk, that the consumer had just saved to disk with the viewer of your choice. So this is a basic overview of how does the UserSpace Tracer work. But now we'll talk about what kind of instrumentation sources we're able to use in the UserSpace Tracer, and in UserSpace, I mean. So the first one is the Tracepoints, which is LTTng specific. So we have a tracepoint heaven. Normally, you would put that in a header in your tracepoint provider. So the first argument is the provider name, which is simply a string and identifying your provider. And then you have the tracepoint main, which is, again, a simple string. And then you specify the arguments that you need to pass to your tracepoint. For example, here we have an integer, which is made with the variable name an int, etc. And then we have the tracepoint fields, defining what fields will be in your trace data. So we pass, for example, we have an integer, which is the name int field, and we pass the expression an int, which we just pass as arguments to the tracepoint. So you put this in your header file, and then in your code to invoke the tracepoint, you simply call the tracepoint function, which is with the provider name that we just specified, the tracepoint name, and the values that you want to save in your trace. So an integer, a long pointer, and a float. So this is the main instrumentation that we support in LTTng UserSpace Tracer. But we also support the SystemTAP statically defined providers. This is another kind of instrumentation that is available in other static instrumentation that is available with the SystemTAP project, which is another tracing project. So we integrated the SDT providers. The integration was a result of a discussion after the Collaboration Summit 2011. And what does that allow is that user that wants to use the LTTng tracepoint can share the tracepoint providers between the applications. They can use the SystemTAP tools with the LTTng tracepoint. Finally, we'll take a look at Uprobes. Uprobes is a kernel mechanism to instrument user space applications that has been merged in 3.5. We have not completed the integration yet in the LTTng project. We've had some roadblocks. We have a patch that was proposed originally for the LTTng module, so this is on the kernel side, so it's not available in the UserSpace Tracer. We need to do some usability improvement on the command lines, so we would like to see like, oh, okay, I want to instrument that program by specifying a file name, and I want to instrument that function. Right now, we can do that. We need to look up the dwarf information for the executable and be able to tell the kernel, okay, this is, you need to instrument at that offset. And finally, the interface is not currently exported by the two kernel modules, so we have to do some KL sim shenanigans, but we'll get there. So we'll take a look now at the trace format standardization efforts that we've been doing. But I know what you're all thinking. You're thinking about that XKCD Comic, so we will end up with 15 different standards of trace format. I assure you that's not the case. We're trying to avoid that. But we need a common open format if we want to interact between tools to allow interoperability of tools. So if I want to use such tools and I want to open it in my custom viewers or my proprietary viewers, that's what a common open format will allow. So the common trace format was a collaboration between the Multicore Association, Ericsson, some folks in the kernel communities, and some in the other tracing projects. Really, the goal is to have a common format for hardware and software traces. If you have a DSP that has tracing data or a custom specific device, or you have the software that has tracing data, such as UserSpace, the kernel, or any virtual machine, we would like to have a common format for all of those platforms. It should be portable and compact. So right now, what we have several tools that are based on CTF. The whole LTTng tool base is, of course, based on CTF, but also a recent patch that was proposed to enhance GDB trace infrastructure to save the tracing data output to the CTF format. And we also have the what? This was integrated? Good. So it's a bit, when it will be available? Oh, okay. Well, that's great news. And we also have the Java trace tool, which is a simple tool to inspect CTF and read and write CTF. So this is a broad overview of the common trace format. What you have is a metadata, which is an ASCII file describing the tracing data format. And you have binary stream binary files that refers to those event description. So you would have, for example, event 0 with these types of fields, and let's say we have 5 int fields. But in the binary stream, what you would see is, okay, I have event 0, and this is my payload, which is, let's say, 5 integers. So it's really self-described in packet-based format. Maybe I could show an example later on. So for more information about that, Mathieu did a great presentation at the Linux Plumber Summit. You can access the CTF specification. And we've also started a new endeavor to verify the compliance of CTF readers and writers with a test suite that is available on GitHub. So now we've looked at how the UserSpace Tracer works, how how can you instrument your applications, and how what kind of data it produces. Now we'll look at some issues that we've had during the development of the UserSpace Tracers. So, like I said, I've shown before, we have a ring buffer that uses a pipe. But the thing is, if the consumer's hand dies abruptly, the application that writes to the pipe can receive a SIG pipe, which is quite bad because it could kill the application, and you don't want that. So okay, let's block let's block SIG pipe around the write. But the thing is, we don't want to be intrusive in the application. We can't modify the whole signal, the whole process signal handling just because we have a pipe. So we came up with a way to only ignore SIG pipe around that write, but not affect the whole process signal handling. And also, if there's any SIG pipe mechanism or sent to the application that it must receive, then it receives it. Another issue that we've had is with thread local storage variable. it's an implementation choice that when you load the dynamically allocated library, you can choose to allocate thread local storage variable only when they're first used. And this mechanism relies on an internal glibc mutex, but that same mutex is also held while running the constructors and destructors. So we ran into a situation that was like this. We are in the constructor of our library. We take the dynamic linker lock, and then we spawn the listener thread, and then we take our simple, we take an internal lock, but then we try to access a thread local storage variable, and then we deadlock ourselves with libc. So that was quite interesting. So the workaround we found for that is to simply force the thread local storage fix up before taking any internal locks within the constructors. Finally, we've run into a kind of issue with some applications out there try to daemonize themselves and detach themselves from the terminal by closing all the file descriptors available. So they do a loop from 0 to sysconf fdmax, and in a fashion like this. So the problem with that is that, remember, we have a socket communicating with the session daemon. And so if the application that demonized themselves close all the file descriptors, we have no more communication with the session daemon, and then no more tracing. So right now, tracing these kinds of applications is quite problematic, and we don't have a fix for that. So we'll take a look at some recent features that we've done and the future work that we intend to do. So for the 2.1 toolchain, we had the network streaming over TCP. So now you can stream tracing data from one host to another. We introduced the relay daemon, which is responsible to receive traces from the network. We also added filtering before any data collection. So a small filter is run before saving data to the ring buffer, which determines if the data is saved or not. It's a C-like syntax, and it runs a simple bytecode interpreter. For now, this feature is only available for the UserSpace Tracer, but we intend to add it to the kernel tracer also. And we added, I would say, a monitoring feature to verify if the applications the session daemon are still running or not. So this is an overview of the network streaming. On the left, you would have your remote host where you want to save your trace, and on the right, you would have the host that you want to trace. So what is important is on the right, the first command, we tell LTTng, okay, I want you to create a session, but with a remote host. And then you do your event enabling, your tracing session setup. You start an application, but in this case, it's the kernel tracer. And then you destroy the session. And on the right, the tracing data will be available after that. So that's for the streaming part. For the filtering feature, this particular example enables a filter with the enable event command. So you want to filter on infield greater than 42 and blah, blah, blah. You do your session setup, you run your application, and then you destroy the session. And in your trace folder, when you point, this is the Babel trace viewer, by the way. When you point the Babel trace viewer at your tracing data, you will see that only the events matching the filter have been logged. So some other features that are currently in release candidate phase. We have per UID buffers. This is some workloads requires the overhead of creating a buffer per process was too high. So instead of that, we have per user ID buffers. So yeah. And then we've added also context filtering, which is an extension of the filtering feature. Contexts are additional payload that you can add to your tracing data. For example, what is my VP ID, what is my VT ID, my proc name. And then you can filter on that right now. Finally, we've added a trace file size limits feature, so you can do in a similar fashion to log rotate. You can have a limitation on trace file size, which is quite useful in the embedded case or any other case. So some future work that we're planning to do is to have a flight recorder mode. So basically you have the events would be written to a ring buffer and other events would be overridden. And then you could, using the command line, you could say, okay, take a snapshot of the buffers and save it to disk. So that's particularly useful in when you have an application that crashes. We could, for example, we plan to hook ourselves in /proc sys core pattern to call the LTTng snapshot command when a core dump is generated. So you would have your application tracing data and your core dump. Finally, we were planning to add Java tracing features. What it would look like, it would be a backend for Java loggers to use the UserSpace Tracer. Some other stuff that we're planning to doing, maybe triggering specific action when filters are met. For example, take a snapshot, or if I have event A and B, well, start tracing, or something like that. We also plan to add compressed and encrypted streaming and storage. And finally, have been accepted in Google Summer of Code. So these are two UserSpace tracing project related. We have dynamic instrumentation support, maybe with dynins or any dynamic. So we would be able to specify with the UserSpace Tracer, okay, I want to instrument that function on the fly. And also, we plan to do an Android port. Some work has been done on Android for LTTNG, but on the kernel side, but not on the user side yet. We have some unfortunate issues with the Android port. So, in conclusion, I just want to say the usability of UserSpace tracing tools have really are really better now, I would say. So, any questions? Yes?
In a production environment, how much overhead in space and
It's
would I incur?
For an enabled event, it's around 200 nanoseconds per event. And if it's the trace point is disabled, it's a simple branch miss.
I would say the
200 nanos for an activated event.
Yeah.
it depends on hardware.
Predicted branch, yeah. Modulo my Raspberry Pi. Okay. What other overhead would be in a production?
I don't remember all the figures. I've put links to benchmarks in the slides at the end, if you want more information about that. Any other question? Yes?
You said the disabled trace points are jump?
It's a if we verify the state of the trace point in an unlikely branch. Yes.
Branch is the predicted branch.
I'm not sure.
If unlikely, you want
Yes.
to trace in this stuff.
Yeah. So when tracing is enabled, it will be slower,
Right. You're unlikely.
Yeah.
which is the correct mentality.
Any other questions? Yes. Okay, that's the question of the when will you merge the kernel modules, I guess.
This is being recorded, so right now I've watched another video where it wasn't, pipes weren't used and it was useless to watch the video online. So,
Yeah, so the question was, so it's been a few years now since there was, I heard discussion between the ftrace and LTTNG about sharing code. So what's the current status of the shared code? Is it?
It's not shared, actually.
Okay.
So we still intend to merge some the ring buffers and stuff like that, but that would be Mathieu's resort, the creator of LTTng.
Okay.
So it's
Thanks.
not done yet.
Yeah. Thanks.
As I'm one of the people involved in that question, I'll give my response. Right now, I've yet seen no rationale to swap out ring buffers. I have yet to see anything that proves to me that it's worth the effort, because it's going to be a huge effort. And I see very little gain, and I really don't. He has never really shown me why he can't use the ftrace ring buffer as well, or incorporate that too. There is a lot of shared code. The Tracepoints, the trace macro that he posted up, he took code from ftrace on building that. So there is actually a lot of shared code. There is a lot of infrastructure that's used. A lot of things that ftrace has done and added. One reason why LTTng can be a module now is because of a lot of work that ftrace has done to open up doors. And if Uprobes needs exported modules, I'm willing to push that for you guys too. I have no problem with that. So there is a collaboration, but a complete merge I don't see in the near future, or if ever.
Also, follow-up question. So it seems that the LTTng might be able to maybe provide the user space tools that ftrace is currently missing, as we saw this morning. Any news on that?
I just asked him about that earlier today, and we're going to Summer of Code and stuff like that. He's going to try to get people to work on that. I have no interest in working on UserSpace, although I've been asked hundreds of times. I feel it's available, and I'm willing to help out. I just don't have the time myself to work on that code. If someone else wants to use the LTTng infrastructure for the UserSpace tracing and hook it to make ftrace and LTTng work together, I'm all for that. I'm not a hater of LTTng. I need to have rationale to do something before I do it, and if there's someone that wants to say, hey, can we merge the two or find a way the two to work together, I'm 100% supportive of that.
The specific idea that Steven was referring to is that now that ftrace output the buffers to a format to disk, we could write a plugin for the Babel trace viewer that converts that format to CTF. And then we'll be able to use it, let's say, within the Eclipse LTTng plugin or any other viewer that supports CTF.
There's one other thing that we need, and that's actually an issue with perf that perf is trying now to solve. So hopefully perf's infrastructure will help ftrace and LTTng, which is basically the timers that are used to synchronize the events within the kernel are not exported out to UserSpace, and it's really hard to interleave events that happen in UserSpace with the events that happen in the kernel because they're using two different completely timers. So we're working on a way to try to find a way that timers in UserSpace and the kernel can actually interact a little bit, so we could interleave, like we could take LTTng, perf, and ftrace, run that, have a way to convert all the buffers using the common trace format or whatever, and then be able to interleave all that data into one viewer.
The application that I'm dealing with, which is a file server, is LGPL.
Okay.
But I've got people who are want to do ports to Apple, God save us, and FreeBSD, which pays bills. What kind of implications for the environment? I know kernel tracing into FreeBSD is difficult, if not a non-starter. I don't care about that, but I'm interested in the other infrastructure around my server daemon that licensing issues would possibly trip over. At least I'm GCC building on that platform.
Okay, so you're asking me what are the licensing issues that you might have on FreeBSDs if you're using the UserSpace Tracer, is that correct?
Yeah, I've got an LGPL server data running on FreeBSD. What are the other issues, given that I'm on FreeBSD, I may trip over it? Because I can run GPL code on it. It's just what things aren't going to be there that I'm going to need.
Well, good question. For the UserSpace Tracer, the dependencies are the UserSpace RCU library, which is the licensing issues for the LTTNG project, we offer multiple licensing, multiple licenses. So it might fit your case. I don't remember all the licenses.
I think the libraries for LTTNG is LGPL.
Yes,
LGPL.
but some trace points are exported under different licenses. So
Okay, because I do know all the trace command libraries code is LGPL as well,
Yeah.
and I got the okay from all the authors to change to that license. So like trace commands libraries LGPL, and I've worked with Matthew on some of his libraries to get authors to sign off switching it to LGPL. So most of the libraries are LGPL that I know of. I don't know about LTTNG, all of it, but I know on the ftrace, the trace command side, we work to do that. Any other questions? Thank you.
thanks.